This can't be right. It's a perfect replica of the Milky Way.
But it's 15 billion light years away. How could this even be possible?
We need to confirm this. Get the telescopes ready.
It's confirmed. This is a perfect replica of the Milky Way. It's almost as if someone copied and pasted it out here.
This could be a massive breakthrough in our understanding of the universe.
We need to tell the world about this. We've just made history.
The parallel universe is an expression we throw around in our lives quite frequently. It is basically an assumption that somewhere far-flung from our universe, there is another world just like ours. That parallel world has characteristics resembling our own, and there is a chance that a civilization just like ours might habitat it. It was thought to be just an assumption until now, but thanks to the evolution of technology, we are exploring outer space at a much faster pace than we ever did. Recent discoveries by telescopes have revealed that this assumption might be true. Yes, you heard it right. Somewhere far-flung the Milky Way, other galaxies seem to have the same characteristics as ours. They might have a planet just like our Earth and stars like the Sun to support their life. So how did scientists discover these galaxies? What does it mean for the future? And is there really a chance that a copy of you and I might exist in outer space? Stay with us as we take you on an incredible journey to the parts of the universe that are billion light years away from us. What exactly is Milky Way? In order to realize the importance of these discoveries, you have to understand the Milky Way and its unique characteristics. Our Milky Way is a large spiral system consisting of several stars and planets. The number of stars in the Milky Way is believed to be around 100 million. It gets its name, the Milky Way, from a Greek myth about the goddess Hera who sprayed milk across the sky. Where the Milky Way is observed from a distance, the formation irregular belt of stars looks like spilled milk, thus the name. Our Earth is also a part of the Milky Way, and the galaxy itself is so extensive that even now, astronomers have not fully comprehended its nature. There is a lot that we still do not know about the Milky Way. Although there are other spiral-shaped galaxies in the universe, none share the same unique characteristics as the Milky Way, or at least it was thought so until now. One of the unique characteristics of the Milky Way is the large and small Magellanic Clouds, which are its closest neighbors. These are two irregular dwarf galaxies in the southern celestial hemisphere that orbit around the Milky Way galaxy and are known as satellite galaxies. Both of these galaxies are members of a local group and show signs of bar structures, which is why they are often reclassified as Magellanic Spiral galaxies. The large Magellanic Cloud is about 163,000 light-years away, while the small Magellanic Cloud is roughly 206,000 light-years away from Earth. Since a lot is still unknown to astronomers and other scientific communities, it is not easy to predict exactly how the Milky Way was formed. Astronomers resort to the simulation and models that are based on the information available to them, and as of now, they cannot figure out how the Milky Way was formed. The inability of these simulations and models to provide a framework of how the Milky Way was formed has led astronomers to assume that phenomena like the formation of the Milky Way are quite rare. However, astronomers have not been able to tell exactly how rare such galaxies are until now. Research conducted at the International Center of Radio Astronomy Research, the University of St. Andrews by Aaron Robotham, has surveyed the universe to identify and study new galaxies. It has revealed that only 3% of the galaxies share the Magellanic Clouds-like characteristics. The study discovered 14 galaxy systems that share some features like the Milky Way, but 2 of them are nearly identical to ours. The survey looked at around 340,000 galaxies, and just 2 of them resemble closely to our Milky Way. It should be enough to explain exactly how rare this phenomenon is. The team leading the research was not really expecting to find twins of the Milky Way for the right reasons. So far, no such galaxy has ever been discovered, mainly because it is extremely difficult to capture them. In order to study the galaxies, powerful telescopes could capture not just the galaxies but also their faint neighbors, like the Magellanic Clouds of the Milky Way. The galaxies discovered by the research are yet to be named. The real question is whether or not a duplicate of a galaxy can exist in a universe, something to which the expression "the parallel universe" refers. Another research tried to explain it when it detected 2 bright streaks while analyzing quasars with the Hubble telescope. The team detected 2 bright linear objects that looked like mirror images of each other, leaving them stunned. It was thought that a duplicate of the galaxy had been discovered, and it baffled the scientists. After years of analysis, scientists were finally able to solve the mystery. The scientists employed two gravitational lensing experts to take a closer look at these bright objects. It revealed that the bright objects were the distorted image of an undiscovered galaxy far away from the Earth. The phenomenon that made the two objects look like exact copies of each other was quite rare and was thought to result from the rare alignment of the background galaxy and foreground lensing cluster. The team of researchers, led by Richard Griffith at the University of Hawaii, chased several theories and took help from a lot of colleagues to solve the mystery. All of the clues added to the conclusion that linear objects were the stretched images of a gravitational lens-distant galaxy located about 11 billion light-years away. However, back when Hamilton spotted these objects in 2013, this phenomenon was not well known. In fact, another researcher, also named Hamilton, accidentally detected these objects via the Hubble telescope as well. The object was rightly named the Hamilton object, but back when it was detected, a lot remained unanswered. Why is it such a rare phenomenon? There are a lot of things that have to go a certain way for something like this to happen. As per the data obtained by the Hubble telescope, the galaxies appeared to be the same and had the same dark streaks across the galactic bulge, a central region where most of the stars are located. The rare but precise alignment of the background galaxy and foreground cluster resulted in twin magnified copies of the same images of the remote galaxy. To put it in simple words, the two bright streaks were images of the same galaxies. It was just that because of the rare phenomenon, it produced two images that looked like copies of each other. So the bright streaks that were captured by the Hubble telescope weren't exactly objects, but rather just images of a remote galaxy. As to why it happened, it was because the background galaxy sent a ripple in the fabric of space. This ripple is essentially an area of greatest magnification caused by the gravity of a dense amount of dark matter. Dark matter is what makes the most of our universe. There is a lot that remains unknown about this unseen glue that holds our universe together. Coming back to the point, as the light from other stars pass through this area of greater magnification, it produces two mirror images of the remote galaxy. Theoretically, it should also produce a third image that could be seen off the site. The phenomenon is also known as gravitational lensing and was believed to be the most plausible reason for the existence of those two bright objects. Even though such phenomena are quite rare, another galaxy was recorded that appeared to be duplicated about 12 times. It is known as Sunburst Arc, and is the classic example of gravitational lensing as it has been captured by the Hubble telescope multiple times at different locations.